All right, Integrated Math 3. This is assignment 1.07. It's called SOHCAHTOA. We'll explain what that means. And what we are going to move into now is a side of math called trigonometry. And if you remember, before we could identify, if we knew two sides of a right triangle, we could figure out the third through Pythagorean theorem, a squared plus b squared equals c squared. Now, trigonometry is a branch of math in which you can deal with an angle and a side. If I know one side and the angle, I can figure out the other two sides. So we're going to learn how that works right now. So the first thing you have to know is which angle are you dealing with. Right triangles always have a 90-degree angle. That's this box here. So that means it's 90 degrees. And the angles in a triangle have to add up to 180 degrees. So in this triangle, 90 degrees plus whatever this angle is plus whatever this angle is would equal 180 degrees. So the first thing we have to know, and this is always given to us, is which angle are we interested in, this one or this one. So if this is the angle we're interested in, it's labeled theta, and that's simply the Greek letter theta, the Greek letter for t, which is simply traditionally the letter that's used to indicate an unknown angle, so, or just a general angle. So we're just talking about some angle theta. So what you have to be able to do is identify the three sides of the triangle in relation to where they are compared to theta. So first of all, in a right triangle, we always deal with the longest side is always called the hypotenuse. Now the other two sides, when we were doing Pythagorean theorem, it didn't matter a squared plus b squared equals c squared. It didn't matter which side you called a and which side you called b. You could just call either one a or b, and it was a squared plus b squared would equal c squared. It had to be the hypotenuse. Now it does matter. So the side that's on the opposite side of the triangle from the angle that we're interested in, theta, is called the opposite. And the side that's next to theta, that's not the hypotenuse, adjacent, the word adjacent simply means next to. So the adjacent side is next to the angle. Now the hypotenuse is also next to the angle, but it already has a name. We call it the hypotenuse. So it's the other side that's next to the angle. So the way I usually do this is I identify the hypotenuse, that's the longest side, that's easy. Then I identify the opposite, so that's all the way across the triangle, that's the side over here, and then I call it the other guy. The other guy is the third side, and that's going to be the adjacent side. So the relationships between these have a very special relationship to this angle. So let's start with sine. A sine is defined as the opposite over the hypotenuse. Okay, so opposite divided by hypotenuse is the sine. And the thing about these functions, sine, cosine, and tangent, is you can compute them on your calculator. And so we'll show how that works in a minute. The cosine is defined as the adjacent over the hypotenuse. So it's this side over this side. And finally, the tangent is defined as the opposite over the adjacent. And that's this side over this side. It's also, once you understand sines and cosines, the sine over the cosine. So we're going to deal only with these three functions, sine, cosine, and tangent. Now even, this is the abbreviation for sine when you're actually putting it in a math function, but you still pronounce it sine even though it looks like sin. And this is still pronounced cosine even though it looks like cos. So when you're dealing with these in a math function, and this is still tangent. We're not concerned with these down here. Not at this point, but we will be later on. So you want to continue to make reference to this front side as you do these problems. Okay? So there's the triangle that tells you what the sides are. Now, one last point. If we were interested in this angle, let's call it beta. If this were the angle we were interested in, not this one, then the opposite would be this one, and the adjacent would be this one. The hypotenuse stays the same. The longest side is still the longest side. So you have to know which angle you're interested in before you can label opposite and adjacent. Okay, let's go ahead and start working some problems with this. Let me go ahead though actually and define what SOHCAHTOA means. And what SOHCAHTOA means is SOH is sine opposite over hypotenuse, right here, sine opposite over hypotenuse. CAH is cosine adjacent over hypotenuse. So I can go ahead and write that here. And finally, tangent is opposite over adjacent. So that's TOA. So that's where SOHCAHTOA comes from. It's just a memory device to help you remember what sine, cosine, and tangent are. Okay, now we're ready to go on and we're going to work through these problems. Okay, so it says correctly identify the ratio for sine P, cosine P, and tangent P. So what that means is we're interested in this angle P. And really it's more appropriately written like that than putting it on the outside. That's okay, but it's really more appropriately written with an arc like that and a P. Okay, so what I recommend you do is always write the relationships every time you do this, okay? Not just the numbers initially. So we're going to start with sine P, and that equals opposite over hypotenuse. So write that every time and you'll end up memorizing these relationships. So what is the opposite? Well, first we have to label the side. So always do that first. So the hypotenuse is this longest side right here. Another way to know the hypotenuse, if one of the other sides is very close in length to the hypotenuse and you're not sure, is it's opposite the right angle. So the right angle goes across, the hypotenuse is on the opposite side. Okay, now we have P here, so the opposite side to P is this side over here, so that's going to be the opposite. And then the side next to it is the other guy, that's the adjacent. Okay, so now we're ready to go ahead. We have opposite, adjacent, hypotenuse. So opposite is 4 square root of 10 over the hypotenuse, which is 14. Okay, and now you can simplify. You should always simplify. So 2 goes into 4 2 times, and 2 goes into 14 7 times. And you can't simplify any further than that. So your answer is going to be 2 square root of 10. And the way you really read that is 2 root 10. You don't have to say square root. If it's some other root besides a square root, then you would say what the root is. But root means square root. And over 7. So that's the angle for sine. Now let's go on to cosine. So the relationship is adjacent over hypotenuse. So just write that. And the adjacent is 6. And the hypotenuse is 14. And 2 goes into 6 3 times, and 2 goes into 14 7 times. So 3/7 is the answer. That is the cosine of P right there. Finally, tangent. Tangent is, and go back to the front page if you need to reference this, it's opposite over adjacent. So if you write this every time, you won't need that reference sheet on the front. You just write these out. So the opposite is again 4 root 10 over 6. Okay, so 2 goes into 4 2 times, goes into 6 3 times, so that equals 2 root 10 over 3, and that's the answer. And that's all these questions are asking you to do. They're just asking you to learn to identify the different sides of the triangle. Okay, let's keep going. Same thing for this one. Alright, so they're interested in angle P, so that's this one right here, P. So the first thing you always do in these problems is identify the sides. So the longest side is the hypotenuse. The side that's opposite P, that would be this side over here, is the opposite. And the other one is the adjacent. Okay, so you've identified your sides. So let's go ahead and do this just what we did above. Sine P. Okay, and the opposite in this case is 4. And the hypotenuse is 5. You can't reduce that any further, so that's the sine of P, is 4 over 5. Cosine. Okay, the adjacent is 3. Hypotenuse is 5. You can't reduce that, so that's the answer for cosine. Finally, tangent. Opposite is 4. Adjacent is 3. Now that's an improper fraction. You could change that to 1 1/3. Won't get into that right now. You're fine to leave it. If the number on top is bigger than the number on bottom, that's fine. Just leave it like that. So that's the final answer for that. Okay, and that takes care of number 2. Let's move on. Same thing. So here's angle P. That's what they're interested in. All right, so identify your sides. The longest side is this one, so that's the hypotenuse. Here's P. You go across the triangle over to the opposite side. That's the opposite. And the adjacent. All right, so let's go ahead. I'm going to just do this silently and follow along. Or actually try to do it yourself first, knowing that you can stop the video, give the problem a try, and then turn it on and see if you got it right. Tangent. That. Okay, there you go. There's the 3 sides. None of those can be reduced, so we just go ahead and leave them like that. Be sure you understand why each of those answers is correct. Opposite over adjacent for tangent, adjacent over hypotenuse for cosine, and opposite over hypotenuse for sine. Okay, here we go. They just keep coming, the same problems. There's the angle P, the longest side. Opposite. And the other guy. Okay, 4 over 24. 4 goes into both of these numbers. It goes into 4 one time, goes into 24 6 times. So 1 times root 11 is simply root 11. Okay, adjacent is 20. Okay, 4 goes into 25 times, goes into 24 6 times, so that's the reduced answer there. 4 goes into 4 once, goes into 25 times, so 1 times root 11 is root 11 over 5, and that's the answer. Okay, you do have to reduce answers, okay? One reason is if you're taking a multiple choice test and they ask you this question, the answers they give you will be reduced. They won't give you 4 root 11 over 20, they'll give you root 11 over 5, so you have to be sure you know how to reduce an answer. Okay, we just keep going on. Again, they're interested in P, so there it is. Okay, the longest side is right here. The side opposite P is over there. And this is the other guy. Okay. Alright, sine P. Opposite is 5. Hypotenuse is 5 root 2. Okay, so the 5's cancel. That becomes a 1 and a 1. So what you have is 1 over root 2. Now, you're not allowed to leave a square root or any kind of root in the denominator. So watch how I get this out of the denominator. And you do it the same way anytime you see a root. You simply multiply the top and bottom by that square root. So the square root of 2 on top over the square root of 2 on the bottom. What does the square root of 2 over the square root of 2 equal? What does any number over itself equal? What does 3 over 3 equal? What does 10 over 10 equal? What does the square root of 2 over the square root of 2 equal? They equal 1. So all I'm doing is multiplying this by 1. That's perfectly legal. So if you're wondering, is it legal to just do that? Sure. if you take this and you multiply it by 1, you end up with the same value. The number's going to look different once I do this, but it's going to be the same number. Okay, so this equals the square root of 2 over the square root of 2 times the square root of 2. And that equals the square root of 2 over the square root of 2 squared. That's what the square root of 2 times the square root of 2 equals, the square root of 2 squared. Well, what's the square root of 2 squared? So let's do a little exercise down here. What does the square root of 4 equal? The square root of 4 equals 2. If I then square that, let me just go ahead and write that. It equals 2. If I then square that, I get back to 4. I get back to the number I started with. I started with 4, I took the square root of 4, I got 2, and then I squared 2, it got me back to 4. Okay, we can get rid of that, I didn't need that there. Let's do it in the other direction. What does 4 squared equal? It equals 16. If I then take the square root of 16, it gets me back to 4. So I started with 4, and I got back to 4. The square and square root are called inverses of each other. They undo each other. So when you have a number and you square it and then take the square root of whatever that gave you, you get back to the original number 4. If you take 4, take the square root of it, you get 2. If you square that, it gets you back to 4. So square and square root are inverses. So if I take the square root of 2 and then square it, that simply equals 2. And up on top, I have the square root of 2, so that is the answer to that. Okay? All right, let's go ahead and do cosine P. I kind of used up a lot of my space, so I'm going to come over here. So cosine of P equals the adjacent, that's 5, over the hypotenuse, which is 5 root 2. So it's the same thing. It's going to give you exactly the same thing. We had that over here, 5 over 5 root 2. Since the opposite and adjacent are the same, it's going to give you the same answer. You just work it the same way. So the cosine of P equals square root of 2 over 2. That's the answer for that. Okay, and finally tangent. Tangent will be a little bit easier. The tangent of P equals the opposite over the adjacent, which equals opposite is 5, adjacent is 5, so that equals 1. Okay, and that's the answer for tangent. So sine, the answer is right there. Cosine, it's the same thing. And tangent, it's 1. Okay, so whenever we come across this, I'll do this again to be sure you understand it. Some students find that a little bit tricky. Okay, let's go on down here, and we're interested in angle P again, so that's this angle. All right, we're going to label hypotenuse. Okay, the opposite is over here, and the other guy is the adjacent. All right, so sine P equals, okay, opposite is 15. Hypotenuse is 17. You can't reduce that any further, so that's the answer. Cosine, adjacent over hypotenuse. Okay, that equals 8 over 15. Can't reduce that any further, so that's the answer. Tangent, okay, and that's going to be 15 over 8. Can't reduce that any further, so that's the answer. We'll just leave the answer in that form. Okay, that's it. Let's keep moving. Okay. I'm going to leave at least 2 of them for you to do on your own, okay? Okay, now they're interested in angle Q, okay? Not angle P anymore. It says right there. We know that because it says it wants Q. So that's the angle right here. That's Q. So it doesn't change any of the formulas. It just changes. If we had been interested in angle P, this would have been the opposite. But we're in angle Q, so this is going to be the opposite. Let's go ahead and label the sides. Hypotenuse, and then this side over here is the opposite for angle Q, and this is the other guy. Okay, so let's go ahead and just work through those. Okay, and 2 goes into 6 3 times, and 2 goes into 14 7 times, so it's 3/7. That's your answer. Okay, the adjacent is this. 4 goes into 4 2 times, into this 7 times, so it's 2 root 10 over 7. That's the cosine. Okay, opposite 6. Adjacent is this. Okay, 2 goes into 6 3 times, and it goes into 4 2 times, so that equals 3 over 2 root 10. Okay, now we have a root in the denominator down on the bottom, so we have to do the same thing we did before. So let me come over here and write this 3 over 2 root 10, and we don't have to multiply the top and bottom by everything in the denominator. It's okay to have 2 in the denominator. That's not a root, but we can't have the root of 10 in the denominator, so we're going to do what we did last time. Multiply top and bottom by 10 over 10, square root of 10 over 10. Square root of 10 over 10 equals 1. And this whole term here times 1 simply equals this. So in other words, you haven't changed the value. This is legal to do this. Okay, so here we go. The top is going to be 3 times root 10. And the bottom is going to be 2 times root 10 times root 10. So that's going to be 2 times the square root of 10 squared. You only square the square root of 10. That's what's being multiplied together. Okay, and we come down here and we'll finish up. So it's 3 root 10 on the top, and on the bottom it's 2. And the square root of 10 squared simply equals 10. So I'm going to come down one more step. 3 root 10 over 20. You can't reduce that any further, so that's the final answer. Okay, so that is that. So I'll draw a little line here so I don't get these together. And we go on to number 8. And this is the last one I'm going to do unless there's a good reason to do 9 and 10. And they are pretty much the same. So I'm going to do 8. Alright, and so we're interested in Q. So for Q, the hypotenuse is always the same. It doesn't matter, doesn't matter which angle you're interested in, but the opposite and the adjacent will be different. So the opposite of Q is this side over here, and the adjacent is this side right here. Okay? Alright, so let's go. Sine. Okay, 3 over 5, you can't reduce that any further. Cosine. Okay, can't reduce that any further. And tangent, that's opposite over adjacent. Can't reduce that any further, so that's your final answer. Okay, I'm going to leave 9 and 10 for you to do. They're done exactly the same way. Remember, you're interested in angle Q in both of these. So there it is. Label the sides. And this one also angle Q, label the sides, and then just go to the relationship that's appropriate. Okay, that takes care of this video on 1.07 SOHCAHTOA, and we will see you on the next video.